Hi everybody, I hope all of you are doing great. In today's lecture, we're going to see a problem called edit distance, and this is the very famous problem of dynamic programming. Let me say that whenever a dynamic programming comes up, which is involving strings, it is highly probable that it will be edit distance, right? It is a very famous problem. It might look very tricky in like beginning, but don't worry, we'll be simplifying this problem and understanding it in a simple way, right? So, edit distance. Given two strings, word1 and word2, these are the two strings given to us, word1 and word2. Return the number of minimum operations required to convert word1 to word2. Okay, so you are supposed to do some operations and you have to minimize those operations, right? Let's see what are those operations. You have the following three operations permitted on a word: insert a character, delete a character, replace a character. So these are the three operations we are having as option, to match, to make these two words match, right? Let me take an example on board and let's understand that. Let's take their own, let's take this example itself, which is like provided by LeetCode, and let's see this as well on the board itself. So I've taken their example and I've modified it a little bit. You are having these two strings, horse and rose, right? You have to make these strings equal to each other, right? Okay. So let us see one by one, right? This character is equal to this character, no need to make any changes. This character is equal to this character, no need to make any changes. This character is not equal to this character, right? R is here, R is not here, right? So can I say instead of this, you can say O. Instead of this O, if I what are the operations I'm having? I can insert, you can say replace, or I can delete, right? These are the three options I'm having. Let's say R and O. Let's say I will insert R in between them. Let's say I will insert R in between them. I've inserted this R. Great, no issues. Now R is matching this R. Okay, RSC is matching RSC, no issues. O is matching with O, no issues. H is not matching with this R, right? H is not matching with this R, right? So if I replace this R, now if I do a replace operation, if I do a replace operation on this R, and you can, in the replace operation, you can replace it with any character. So this R can be replaced with H, right? So how many operations have I done to make these two strings equal to each other? I have done two operations. I have done two operations, right? Let's take another example. Let's understand this particular case, like all the operations we are having clearly. Let's say we are having a string ABC. Let's say we are having a string ABBCC, right? Okay. So one easy method you will find that if you delete this B and you delete this C, you will be having ABC, the string itself, right? If I delete this B, right? If I delete this B from here, if I delete this C from here, the end string I'm having is ABC. Or I can do one more thing. Instead of doing two deletion operations, I can do two addition operations as well, insertion operations as well. So I can insert a B in between these two. You can insert in between anything. You can delete in between anything. You can replace any character with any character, right? So by replacement, we are not saying that I am replacing the characters, or I am not swapping the characters. We are not swapping. B, C. I've inserted these two characters and now both of these two strings are equal. That's great. That's great. Both of them have become equal. After doing two insertion operations, either I can perform two insertion operations on this small string, or I can perform two deletion operations on this large string to make them equal, right? I hope this thing is clear that how we are doing insertion and deletion operations. Let's take a last example which will demonstrate the replace, you can say, uh, test case, right? So A, B, C, C, A, B, C, D. We have to make this, both of these two equal to each other, right? So can I say I will delete this D and then I will insert a C? How many operations have I taken? Two operations. Yet instead of deleting and then insertion, right? If I directly do, like here was D, right? Here I was having D. I will directly replace this D with any character. I'll replace this with C itself. I'll replace this with C. And after the replacement, you can see both of the strings have become equal. I can also replace this C with a D as well to just make them equal. And yeah, this is the thing of a replacement itself. You can or cannot do any operation. It's up to you. If the strings given to you are already same, zero operations, you have to perform zero operations and the string will be equal to each other. That's it, right? I hope this is clear. Let's take some more examples and understand it more clearly. For example, if I give you a string A, B, C, D, and if I give you another string which is empty, what is the minimum number of operations can you do? You can tell me in the comment section. I hope you have done, right? A, B, C, D. Either I can delete all the characters from this string and make this string as well as empty string, or I will add A, B, C, D in this empty string and I'll make it equal to this, right? So either I can do 4 deletions operations or I can do 4 insertion operations, but no matter what, minimum operations are going to be 4. Replacement operations will not help me here because I want to delete or insert character itself right here, right? So I hope these cases are clear. I hope you are able to understand what are these delete, replace, insert, whatever these operations are. I hope the test cases are clear, right? I've covered one of the base cases as well, but don't worry, we'll discuss it again. So let us look at this particular thing, right? And if you're wondering what was the base case, this was one of the base cases, right? If one string becomes empty, one string is having, don't worry, I'm going a little bit ahead of my pace. I hope this much thing is clear to you. I hope you are able to understand the problem statement itself. Let us look at the explanation part of it and then try to derive some recursive solution out of this. So we are about to discuss the recursive approach for this problem. But before that, I want to share that, how do I get to know that we can apply recursion in this problem? How can I get to know that we can apply DP in this problem? This is a common doubt which, you all are asking, right? So what actually we are doing in DP problem? Tell me simply, what actually are we doing? Here, whenever we are writing the recursive code, am I not trying to explore all the possible, you can say, all the possibilities, right? When we tried the recursive problem for, let's say, gold mine problem, right? I tried to go at every path, right, which was possible. That was recursion. In recursion, what we are doing, I'm not talking about DP, I'm talking about recursion. What are we doing in recursion? I'm trying to map out all the possibilities, correct? And that is what we are doing to trying to do here itself. DP is just an optimization of recursion itself, right? If you are able to see a recursive pattern in the problem, if you are able to see that yes, you can explore all the possibilities, right, which might arise, right, you can definitely apply recursion on that, right? And then you have to decide whether you can apply DP or that, like whether you can optimize that recursion or not. It is like something else, right? But recursion, like, of course, this recursion should be very clear before discussing the DP itself, right? So let us try to map out all the possibilities for this particular test case, that what can happen, what cannot happen. According to that, we are going to answer itself, right? So let's see. Horse and rose, these are the two strings I'm having. I'll be looking at the last characters. E and E, they are equal. If the last characters are equal, my friend, what am I going to do? Can I say they are already matched? I don't need to do anything, they're already matched. So I'll call that, last characters are already matched. The remaining characters, what is the best you are able to do? So what are the remaining characters? Can you see? These all characters are the remaining characters, like this S. These all characters are the remaining characters, correct? E and E are done. Their task is done. These all characters are the remaining characters, correct? Whatever is the cost to make this string equal to this string, that is the cost to make equal to this string, this string equal to this string. That is it. Because last characters are equal. I don't need to perform any operation to make them equal, right? They are already equal. So if the last characters are already equal, remaining characters, whatever is your cost to become equal of each other, that is what my answer will be, right? So we are making only one call when E and E, like the last characters, are same, and this call is simply saying whatever your answer is, that will be my answer itself, because I take no operations if characters are equal, right? I'll be this step cannot take in more operation, right? Any operation, right? We don't need to perform any operation itself because these characters are equal, right? Okay. Now, like, and this is of course a valid thing, because if these are the two strings I'm having, right? If I add a E in front of both of them, right, will their answer change? No, because both of the last characters are equal. Whatever is the answer of the remaining characters in both the strings, that is the answer for this case itself. I hope this case is clear, when the characters are equal itself, right? So what are the cases when the characters are not equal? And in this case as well, you can see that S is actually equal to S. The last characters are equal. So whatever is the answer of the remaining string, what is the remaining string? Tell me. HOR and RO is the remaining string. RO is the remaining string. and whatever is the cost of making these two strings equal to each other, that is the cost for this, and that will be the cost for this as well, because last characters are always, like in this case you can see they are equal, right? Okay, let's move forward. Let's try to map out what is the cost. We are trying to answer what is the minimum cost of operations, what is the minimum number of operations we want to perform in order to make this string equal to this string. I hope this is clear. We are going to return, again I'm repeating, we are going to return from this particular case of recursion, I am going to return the minimum cost to make this string equal to this string. I hope this is clear. Okay. You can see R is not equal to O. Last characters are not equal to O. I am always trying to compare the last characters itself, because at one point I'm looking at two characters, one from string 1 and one from string 2. Last characters I'm looking at, and they are not equal. So when the characters are not equal, what all things can I do in order to make them equal, right? Look at this closely. Look at this closely. So one thing I can simply do, there are three options I'm having. There are three options I'm having. Let's see. The first operation is that I will replace. I will replace. So if I replace this O with a R, will I be able to achieve the same string? Yes, definitely. You can you can also say that you want to replace this R with a O. The same thing, right? I am saying that if I replace this O with a R, I'll be having HO is the remaining, right? HO is the remaining, and R is the remaining in the second string itself. Now, why have this string reduced, right? You can see when I will replace R with this O with R, these two characters will match. And if the characters are matching, right, if they will match after doing one operation, can you see that if they will match, the remaining answer will be like found from the remaining characters of the string. I hope this is clear. Again, I will repeat, the last characters were not equal. The last characters were not equal. And if the last characters are not equal, I am replacing the last character of one of the strings. Let's say I am replacing this O. I am replacing this O with the R. If I replace this O with the R, can I say then they will match? Why am I replacing it with R? Because I want to match with this R. Right, that's why I'm replacing it with R. So when I will replace this O with the R, the last characters will match, and the rest of the answer will be found by the remaining characters. That's why here I've written HO and here I've written R. I hope this is very clear to you all, that what are we doing in replacement operation, right? So this was the replacement operation. Let us talk about insertion operation now. So for the insertion operation, insert. In this insertion operation, these are the two strings I'm having, and R is not equal to O. Can I say if I insert a R after this O, if I insert a R after this O, these two R's will match. You can see these two R's will match. But what are the remaining strings? HO is the remaining string from S1, but from the S2, this O is still intact. I have not used, or you can say utilized this O. I have added extra R. That R was responsible to kill the R from S1. I am saying kill, right? So this R is responsible to destroy this R from S1. That's fine. But this O is still persisting, right? It is not matched with anything else. So this O will persist. RO from S2, HO from S1. S1 is not having the R because it got matched with the inserted character. RO is having a O because we inserted a character in ROR, right? And the inserted character took the beating, right, with this particular R, right? I hope this is clear, right? I'm not actually inserting, I'm just hypothetically saying that if I'll insert that character which will match this character itself. Definitely, why would I want to insert a D here? Why would I want to insert a D here? Why would I want to increase my work? There's no point of increasing the work, right? So I will insert whatever character like is there. They are not asking us to what the character we are inserting. I'm just saying that if I insert a character, any character here, that character will definitely match because I'll add the same character. If R is here, I'll add R here, and that will match this string, and the remaining strings will be HO, the string 1 with a deprived last character, and string 2 which is as it is because I inserted a character in string 2. I hope this is clear to everybody. I hope HO and RO, why I have written HO and RO here, I hope this point is clear to everybody, right? Let us look at the delete operation. If I delete, now if I am deleting this O, I'm saying that I'm not considering anything here. Let's delete this O, right? Then the answer, remaining answer will be found from where? If I delete this O, HOR is the remaining string from string 1, HOR is still remaining, and from the string 2 only R is remaining. So whatever is the cost to make both of these two equal, that is the cost for this, definitely. And of course, no, I'll add one as well because I've deleted here, right? That step I'm not talking about. Let's move on a little bit further and you'll understand this more closely when we move forward. Let's look at this H and HO and R. Okay, let's look at this very interesting test case. HO and R we are having here. Okay, no issues. Last characters are not equal, as you can definitely see. No, here the last character is O, here the last character is R. They are not equal, right? So if they are not equal, I'm having three choices. I'm having three choices. What are the three choices I'm having? Let me draw these three choices here. So the first choice I'm having is to replace. Second choice I'm having is to insert. The third last choice I'm having is to delete. If I replace this R with a O, if I replace this R with a O, from the first string, R will be matched with O, definitely. Because like, oh, this, when I'm replacing this R with the O is here, and this O will match with this O. In string 1, I am only left with H. In string 2, I am left with nothing, my friend, because R got replaced by O and it got utilized by matching with this O, right? So H is the only character coming from S1, but S2 is empty now because I have utilized all the characters from there. And can I say that if one string is empty and the string is filled, the only options I'm having is either I will be inserting these many characters in, you can say, this string, or I'll be deleting all the characters from S1 to make this equal to empty string. So what are the number of operations will I be performing, right? This example, do you remember this example, right? ABCD. I want to make ABCD equal to empty string, and if I want to do so, either I can add ABCD to empty string, make them equal, 4 operations, or I can delete all the characters from ABCD and make it equal to empty string. That's it, right? So whatever is the remaining string, that is the length of operations I want to do. So from here, I'm going to return a 1. From here, I'm going to return a 1. And since I replaced the R from here as well, it is actually 1 plus 1. Because here I did a replacement operation. Here I did a replacement operation for this, and like that's why I'm adding this one, and this was the answer coming from rest of the people which they were able to make. I hope this is clear to everybody, right? Let's move forward. If it's not clear, don't worry, we are going to do the complete iteration. You'll get everything clear, right? H, O and R, we want to perform an insertion operation. So if I want to perform an insertion operation, I'll be inserting O in the end of S2. Great. And if I'm adding this O in at the end of S2, what are the remaining strings? H is the remaining string from S1 and R is the remaining string from H2. S2, yes or no? Right? Because I inserted O here. This O matched with this O. This is the remaining from S1. This is the remaining from S2. I hope this point is clear. Great. Insertion is done. Let's talk about deletion. Right, let me remove this O itself. And this O is adding like in an imaginary way. I'm adding, right? In an imaginary, I'm not actually adding it in. It's just an imaginary thing which I'm doing, right? Now, if I delete like R and HO, if I delete this character from S, we can say S2, what will I do? If I'm deleting this particular character, now the remaining strings will be HO and nothing from S2. And can you see what are we going to return from here? What are we actually going to return from here? We are going to return, simply, we are going to return the number of characters from the remaining string, which is 2. Plus this delete operation I performed. Due to this delete operation, I have to add 1 as well because, to delete and then get the answer, that is a total of 3 operations which I did, right? Okay, great. No issues. Okay, great. Or, I can, replace, this -1 from here. I'm not writing -1 here. I'm saying that this I'll be able to make equal by doing 1 operations. I will able to make these two things equal by making 2 operations. Great. Let's talk about H and R. The only thing which is remaining is H and R, right? H is not equal to R, last characters are not equal. First option, second option, third option. If I replace this R with H, the remaining strings are If I replace this R with H, matched, nothing is remaining in both the strings. My friend, nothing is remaining in both the strings. And if nothing is remaining in both the strings, how many steps do I require to make empty strings equal to each other? Nothing. I'll be returning 0. I want 0 steps to make them equal. Okay. These two strings equal. I'm not talking about these strings. I'm talking about to make these two strings equal, I'm going to return a 0. Replace insert. Replace insert. If I insert H in front of R, if I insert H in front of R, what am I going to have in the remaining string? H is going to match with H, right? So from S1, I'll be having empty string. From S2, I'll be having a R only because I inserted H after R. So R is still persisting, right? I hope this is clear. Great. And of course, if one string becomes empty, what is the length of the other string? That is how many operations I need to do to make them equal, right? Either I will insert R here, that is one operation, or I will delete this R, that is also one operation. So I am going to return a 1. Whenever any string becomes empty, whatever is the length of other string, you have to return that itself. Great, great. Let's talk about this test case now. Let's talk about this test case. ध्यान से देखना. Delete. If I perform a delete operation on this R, if I delete this R, I'm saying that I'm deleting this R. So H is still remaining. R is deleted. So nothing is there in this string. And can you see this is an overlapping sub problem right here? My friend, this is definitely overlapping sub problem. And because of this overlapping sub problem, you will of course see in this recursive tree that there are overlapping sub problems, right? This is the, you can say, optimization you can perform, right, by remembering the answer for this. So, and of course, whenever any string becomes empty, I return the length of the other string. 1 is the length of H, so I'm going to return 1 from here. Now, for the first time in the history of mankind, we are going to return some answer, right? ध्यान से देखना. Full focus. H and R. To make this equal to each other, I need O. To make this equal to each other, I need 1. Right? Sorry, O was 0. I need 1 here. To make these two things equal to each other, I need, you can say, 1. Right? Great. So what is the minimum number of operations out of all of these? 0. Right? And can I say that I'll be able to make H and R equal to these two things, right? Empty strings, by doing one operation. If I replace this R with H, I'll be achieving this thing. That is one operation to achieve this, and I'm able to make these equal to each other in 0 operations. So how many total operations I did in order to make H equal to R? One replacement operation, and rest of the people are able to make themselves equal in 0 operations. So can I say 1 plus 0, which is 1. So I am going to return a 1 from here. I hope this point is pretty clear to you all. Again, I will repeat, H and R were not equal. So I tried all the options in replace, insert, delete. This is giving me the minimum, you can say, thing. I want to return minimum, right? So this is giving me minimum number of operations that if somehow I am able to convert H and R into this empty strings, I'll be able to make these empty strings equal by doing 0 operations. Great, great. But how many operations do I require to make these H and R to empty strings? Can I say 1 operation? If I replace, that will be 1 operation, right? So 0 plus 1, that is 1. I hope this is clear. Now let's move forward. HO we are standing on. So this is also done. So for this particular call, everything is done. You can see I'm having 1, 1 and 1. Great. 1, 1 and 2. So minimum operations, either I can replace or I can insert as well. Both of them are giving me, you can say, 1 as answer itself. That's great. That's great. No issues. So I'll try to do what? I'll definitely try to, let's say, choose this one, any of insert of replace operation, and to make, let's say, I'll choose replace operation. Any of them I can choose. I'll choose replace operation, and to make this replace operation, this is able to, like, we are able to convert. This one says what? This one says that to convert H to empty string, you need 1 operation. How many operations do I need to convert this to this? A replacement operation. So 1 plus 1, which is 2. From here I'm going to return a 2. From here I'm going to return a 2. Let's return a 2 from. And you can definitely see here, if you want to make these two things equal, delete this, replace this. Simple. That's it. That is it. Right. That is it. Or you can say replace this with O and delete this H. That's it. That is what we are actually selecting. So great. So 2 operations I'm able to do if I want to make both of these two things equal. I hope things are getting clear to you all. Up H, O and R, O, great test case, very good test case. And here we are going to see repeating sub problem as well. You can see endpoints are equal, and if the endpoints are equal, I don't need to perform any operation. Rest of the answer, whatever answer the remaining strings give me, H and R give me, that is the best I'll be doing. That is the best I'll be doing. That is great. That is great. And what is the cost of making H equal to R? Can you see this is an overlapping subproblem again, right? That is why I make the whole recursive trees, right? This will actually help you to see the overlapping subproblems, and this will actually help you to, analyze that why are we doing dynamic programming. H is equal to R. H and R always can be converted to each other in one operation, right? So without calculating this, I'll just refer to whatever answer are calculated before using memoization. This is what is memoization. I'm going to return a 1 from here. I'm not calculating answer from there. No, friend. Why? I've already calculated this once before. Why should I calculate this again and again? There's no need. So I'll simply say that I'm just going to return this one itself, and H and O, this will return this as it is, because there's no operation to make O is equal. So I'm going to return a 1 from here as well. All right. So HOR, this is the thing we are having. Let's analyze this. So for HOR, you can see R is equal to R. Last characters are equal. So when last characters are equal, whatever is the remaining answer, that is whatever the remaining string gives me, that is what I'm going to return. And have I calculated HOR before? Can you see this? Repeating sub problem, my friends. So what am I going to do from here? Full focus, right? So that is a dialogue I use a lot in my classes. So I don't know why. Okay. So HO and R, repeating subproblem. This returns to. I'm not going to do this whole iteration again. No, no way. It is not only this optimization of dynamic programming is not only helpful in decreasing the time complexity, but it is also helpful to make the video shorter, right? Because I don't need to calculate this again. I don't need to draw the same tree again, because this same tree is going to be drawn here, right? Why to do the repeated work? That is the optimization. So HO and R will directly return me whatever they returned before. So they return 2, I'm going to return these two things were equal. So whatever answer comes from front, I'm going to return that itself. So I'm going to return 2 from here. Now you can definitely see 2, 1, 2. What is the minimum? 1. And to make HORRO equal to HORO, I did one operation. So 1 plus 1, which is 2. I'm going to return a 2 to this. Return a 2 to this, right? And this thing, S was equal to S. So this is going to return this 2 as it is. E was equal to E. This was going to return 2 as it is. And in 2 operations, I'm able to make horse into rows. Let's see how. Horse into rows. Let us see how. Alright, let's see how. ध्यान से देखना. What I'm going to do, I'll delete this. I'll make this R. That's it. Rows. Or I can say something else as well. Let's say let's do one thing. I'll delete this, right? Okay. Let's see how we are actually doing it. Okay, in the first thing I'll let's say I'm doing an insert operation, right? So I'm doing an insert operation. So basically what I'm doing here is, let's analyze this very closely. So I'm doing is that I'm inserting a R inside this. I'm inserting a R inside this. And I'm deleting, you can say, if I insert an R inside this, HORO, H and R are remaining. Yes, RSC is equal to RSC, HORO is remaining. So if I simply, replace this R with the H, that's it. 2 operations. Again. In rows, I inserted a R between O and S, and then I replace this R with the H. So that is what we are doing. Insert, and then you can say this HR simply selects, you can say insert operation, or you can say whatever, delete operation as well, right? So that is it, right? So in 2 operations, let us verify this answer and let's look at the lead code example. So I have given a dummy, you can say, return statement. I'm not concerned with the code itself. You can see when HORSC and ROSC is there, the expected output is 2, and 2 is what we are getting. I hope the explanation part is clear. Let me generalize the approach and write the recursive approach itself. So to generalize, right, we are going to look at this tree itself, which we've drawn here. First of all, the base case, right? Whenever any of the strings become empty, return the length of the other string. Right, this is the base case, right? Whenever any of them becomes empty, I'm going to return the length of the other string. That is the first case I can say. Second case is what? When s1 of ith index, right? They are the last indexes I'm considering. I'm not breaking the string actually. When ith index of s1 is equal to s2's jth index, you can see now when I is equal to j, right? I will always point to s1, j will always point to s2. When ith character of s1 is equal to jth character of s2, I'll simply say that, I'll simply return whatever you can say recur for, whatever best other people are giving me, I minus 1, j minus 1. That's it. As it is, I'll return this and simple. Great. Right. Now, third option is what? Third option is what? When the strings, when the characters are not equal, when the last characters are not equal. So, when the last characters are not equal, if I do a delete, you can say if I do a replace operation, if I'm doing a replace operation, can I say I'm doing one operation plus whatever recur? Let me write in some good handwriting. Recur for, you can see when we are doing replace operation, can you see that when we are doing replace operation, both of the strings are getting shortened, right? So 1 plus I minus 1 comma j minus 1, because you can see O got replaced by R. Both of them matched. Remaining string are both the strings I'm shortening, right? So I hope this is clear that when we are performing the replace operation, both the answer what I want to get from behind is I minus 1 from s1 and j minus 1 from s2. Whatever is remaining in s1, whatever is remaining in s2, that is what I want to get. If in simple terms, if you want to understand, I am replacing O with R. Whatever is the cost to make HO equal to R, that will be the answer for this, right? So great. One operation because of this replace operation plus whatever is the cost to make the remaining strings equal. Great. Now delete, or I can say insert operation. What is the cost of insert? 1 because of this insert operation, and recur. Since I inserted in, you can say j, I'm saying that I'm inserting in the second string, right? So if I'm inserting a r here, right? I'll just zoom in a little bit. If I'm inserting a r here, can you see if I'm inserting a r here? These two r's will match. First string will be shortened, second string will remain the same. So what am I actually doing? First string will be shortened, second string will be remaining the same because I inserted in the second string, right? I'll not be reducing. That last character will still be persisting, right? So whatever is the answer I'm going to get from here, that's the answer itself. Now let's see if I'm delete 1 for delete operation plus recur for. In delete operation, you will see that if I'm deleting this last character, you can see R was not equal to O. If I'm deleting this O, first string is as it is, you can see. Second string is reduced by 1, size is reduced by 1. So what am I passing here? I as it is because first string is remaining as it is, and j minus 1 because size is reduced by 1. Whatever is the minimum of them, minimum of replace, insert, delete. That is what I'm going to return. And this is the generalized, you can say, solution for this problem itself. I hope this is clear. A little bit bad handwriting, but again, you all know the reason. Many secret services use my handwriting for their secret missions, right? For encryption, decryption. So I need to keep this kind of handwriting, right? So yeah. So I hope this is clear to everybody. I hope edit distance recursive part is clear. Let's quickly convert this into code, then memoization, then tabulation. So in this whole coding segment of the video, I'm first going to write the recursive solution. Then I'm going to use a trick to convert that recursion to memoization. Then I'm going to use a trick to convert that memoization into tabulation. So if you want to know what tricks I'll be using, you have to watch this whole series from the very beginning, because I've explained these tricks along the way itself. And if it is not clear how am I doing, right? Those tricks are explained in this whole series. We are following a series itself. I'm trying to make DP easy using these tricks itself. right? So please watch the videos which is before this to understand the code more clearly if it's not clear right now, right? It might look that it's magical what I'm doing. It might look that how am I doing all this stuff, but they are simple tricks and they are logical tricks, right? So let us get right into it. Let's code this out quickly, right? Coding is not the part where I like, spend a lot of time. It is always on the board, and I encourage this as well. Whenever you are approaching a problem, just try to spend as much time as possible on, you can say, a pen, paper, or a board itself, right? So, okay, I hope this is clear. Let's, code this out and then move forward. Uh, Return recurse. I'll simply write recursion function here. Word one, I'll pass. Word two, I'll pass a string word one dot length. Let me get their lengths. Integer m is equal to word one dot length. Integer m is equal to word two dot length. Great. Here I'm going to write n minus 1 comma m minus 1 because last characters always I'm concerned with, right? You can do with the first characters as well. I want to you can say save the nature of, you can say, memoization, which is top down, right? That's why I'm taking from last characters itself, right? So public int recur string s1 string s2. Great. Integer I, integer j. Great. Now for the base case, right? If I becomes equal to s1 dot length, or like if I becomes equal to s1 dot length, I is finished, string first is finished, I'm going to return the length of string 2 because that will be the cost of converting s2 into an empty string. Delete all the characters from s2. That is the length. That's it. Second base case, if j becomes equal to s2 dot length, if second string gets finished. So if second string gets finished, to make the first string into equal to an empty string, I want to delete all the characters from the first string, or I want to insert the number of characters in the first string into the empty string. So that is s1 dot length. I hope the base cases are done. If s1 dot char at I is equal to s2 dot char at j, what am I going to do? S1 dot char at I is equal to S2 dot char at dot j. Return recur for S1, S2, whatever is remaining in string 1, whatever is remaining in string 2, whatever they are able to make, whatever is the cost to make remaining string is equal, that is what my cost is, because last characters are equal. I don't want to do any operation right here. Why do I want to do any operation if the last characters are equal, right? Why to waste operations? I want to minimize the number of operations, right? So this case is clear, I hope. Then great. Okay, let's move forward. Rest of the cases, if I replace the last characters, I'll be doing replacement operation. That's why I'm writing +1. And if I'm writing +1, I'm replacing, so recur for S1, S2. And if I'm replacing the characters, last characters will match I minus 1, J minus 1. Integer insert is equal to 1 plus. Since I'm inserting, I'm adding 1. Recur for S1, S2. Now I'm inserting in second string, right? If you look at this example, I'm inserting in the second string. I'm explaining it again. So if I'm inserting it in the second string, you can say if I'm inserting R in the second string itself, if I'm inserting here, this R will be matched. So string 1 will be reduced. You can see HOR become HO, but RO is remaining the same because from string 2 we didn't do anything, right? So I minus 1 J, insert, delete 1 plus because we are deleting, that's why I'm adding 1. Recur for S1, S2. First string will be remaining same because I'm deleting from the second string, that's why I'm writing J minus 1 here. I hope this is clear. What am I going to return? Return math.minoff, replace, comma, math.minoff, insert, comma, delete. Great, great. So this is the recursive code itself. Let us try to run this code itself and see if it's working. All right. Okay, so string index out of bounds. Definitely, I don't want to write 0 here. I want to write if this I becomes less than 0 or j becomes less than s2 dot length. Right. Because I'm going from n minus 1 towards 0. I will not be reaching s2 dot length, right? So this was my mistake here. So I'm returning 6. Expected output is 2. Let's see what is going wrong. So of course, some of you might have detected my mistake. And the mistake is that I was returning the lengths of the both strings, right? I don't want to return the whole length of the whole strings itself. If I becomes less than 0, if there are no remaining characters in string 1, I want to just return the remaining characters in string 2, and that is j plus 1, right? That is j plus 1. This means that if j is on 0th character, that is the 0th character which is remaining. So j plus 1 which will be 1, right? So j plus 1 is the number of characters remaining in string 2, and you can say of course, when j becomes less than 0, I want to return the remaining characters in string 1. So I plus 1. I hope these 2 points are clear. J plus 1 and I plus 1. Remaining characters in string 2. Remaining characters in string 1. Great. Because according to I and j only, I'm able to decide now that where am I standing, how many characters are remaining, right? For example, if j is on index 2, right? How many characters are remaining in string 2? 0, 1 and 2. 3 characters. So if j is on index 2, I'm returning j plus 1. That is saying 3, right? 0, 1 and 2, which is 3 indexes, right? 3 characters. I'm running, it's running fine. I'll not be submitting here because of course it will not be able to pass. We have to optimize this code to Memoisation, and let us see that itself. So of course, to convert this recursion to Memoisation, I'll just copy this code, paste this here. Simple trick we follow. Wherever I'm writing return recur, I'll write memo. The memo function, I'm renaming the function. Now I want to pass a DP array, which will remember the states of recursion. Can you see these are the two variables which are getting changed? So how many dimensions my DP array will be having? 2 integer DP. Great. 2-dimensional DP I have created. That is great. That is great. Now what am I going to do? Wherever I'm writing memo, of course I have to pass DP here as well. Great. Here also I'll pass DP. Recall and remember. So if DP of I comma j is not equal to -1, I'll be initializing every index in this 2D array with -1, stating that I have not touched that. If DP of I comma j is not equal to -1, I'm going to return DP of I comma j, stating that I'm remembering the solution, I'm recalling the solution. If DP of I comma j is not equal to -1, this means that I've calculated the answer for that, and I will return that answer. And if I have not calculated, that will be -1. I'll calculate it, and at the time of returning, dp of I comma j is equal to memo. Here also at the time of returning, dp of I comma j is equal to memo, and this is the optimization itself. The code will be running in n square time complexity, and this is it. This is the memoization function. Let me create the dp array itself. Integer 2D array dp is equal to integer n comma m. For integer I is equal to 0, I less than n I plus plus, right? I'll simply do arrays dot fill dp of ith array, I'm filling it with -1, stating that all the indexes in this dp2d array, I'm filling them with -1s. I'll return dp here, and of course, instead of writing recur, I have to write memo here. Let's run this. The code would run just fine. Let's see. Okay, let's try to submit this. It's passing with flying colors. Okay, so let us quickly convert this recursion memoization to tabulation itself, and then wind up the video. So to convert this memoization to tabulation, I'm going to follow another trick which we have discussed before. This is the trick where I create DP very easy. I'll do what? If the tricks are not clear, believe me, you will not be able to understand what we are doing. I have discussed the logic behind these tricks. If you are able to follow these tricks, you'll definitely understand that what is happening behind the scenes. So please watch this series from very beginning if you're not having the complete understanding of these tricks. These are the magical tricks, and some of you might think that what actually on earth am I doing here while applying these tricks. Just look at those explanations from the very beginning, like for you can say the beginning videos of this series itself, and it would be very good if you follow the series from very beginning, because I've generalized solutions for every problem into these tricks itself, right? That's why this playlist is called DP is easy. You'll find somewhere here the I button for that itself, right? So you can follow the whole complete guide on the dynamic programming on that. Okay, so again, public int tabulation is the first thing we do. I'll pass string word1 s1, string s2 s2, and I'll pass 2D array dp as well. Great, 2D array dp as well. Now this is the recursive function I'm having. I want to start how many loops? 2 loops, because dp is 2-dimensional. I want to start 2 loops, and both of those loops should start from index 0 itself, right? You can see here that I want to start those loops from index 0 itself. That is great. So because we are going from n-1 to 0th index itself, right? So I'll do what? For integer I is equal to 0, I less than n, I plus plus. For integer j is equal to 0, j less than n, J plus plus. Of course, N and M are the length of the, you can say, strings as well, right? And that's the dimensions of DP as well, right? Now inside these two loops, what do? I'll simply copy this code, paste this code. I'll fix the indentation. Let's fix the indentation for this code. Okay. All right. So I've pasted this code here. Let us see what we are going to do now. Great. First, let's remove the memoization calls. So I'll remove this DP here, like recall thing. I'll remove this. Wherever I am writing return, I'll replace it with remember and continue. These two are out of bounds condition. We'll be handling it later. This return statement, I can simply remove this and I can continue from this step. Great, no issues. I can say here also I can simply remove this return statement and it will automatically continue. So all the return statements are removed and they are replaced by continue statements. Definitely great. Wherever I'm calling memoization, I'll try to access the DP array. I'll try to access the DP array. So I'll say DP of I minus 1, DP of I minus 1, comma, J minus 1. That's great. You can see here. Here I'm going to access DP of I minus 1 J, because here I'm trying to access DP I minus 1 comma J. Here I'm going to write DP of I J minus 1. That is great. DP of I J minus 1. Great stuff. No issues. Okay. So now what I'm going to do? I'm going to handle these cases. These are the remaining cases now. I'm going to handle these cases. Where can I go less than 0? Can you see here I can go less than 0. Here I can go less than 0. So what am I going to write here? If I minus 1 is greater than equal to 0, right? If it is, or we can say if it is, if it is greater than equal to 0, I'm using ternary operators. This is also we have discussed in previous videos in this series itself. So do watch the series to understand the code itself. If I minus 1 is greater than equal to 0, then try to access this index. Else I minus 1 is greater than equal to 0, na? So else I'm going to write here I minus 1 is less than 0, na? So write here J plus 1. Great, no issues. Here you can see that definitely, if you can say here also I'm going to write let's see. Okay. So here J can go out of bounds. So here I am going to write if J minus 1 is greater than equal to 0. Great. Else I'm going to write here what? I plus 1. Now this is remaining, right? Here both of them can go out of bounds. I can go out of bounds or J can also go out of bounds. So let me separate it like you can say let me handle this separately itself. Now to handle this separately, I'll do what? I'll initialize this replace with 0 itself. If I minus 1 is less than 0, I'll say replace is, you can say, equal to I'll say J plus 1. Else if J minus 1 is less than 0, replace is equal to I plus 1. Else replace is equal to this. Correct. I hope this is clear. That's how we are handling replace itself, right? If none of them is there, then only I'll try to access this index. If I becomes less than 0, access J plus 1. If J becomes less than 0, access I plus 1, as this, right? So this is the case itself. I hope this is clear. I hope this is done. I am going to return here dp of n minus 1 comma m minus 1. Here the answer will be stored because here we are calling n minus 1 comma n minus 1. So answer will be stored here. These are the small tricks which I have discussed. Let me call this return tabulation, and in this tabulation word 1, word 2 and DP array. These are the three things I'm passing. Let me run this code itself and see if it's working. Okay, word 2 dot length. Okay, so here I'm not initializing with word s1 and s2. Great. Let's run this now. Okay, accepted. Let's try to submit this now. And great, it's giving me a runtime error. Let's see where it's giving. So both the strings are empty. Okay, if both the strings are empty, right? If both the strings are empty, this case can be handled, right? And you can see this can go, you can say, wrong, right? If both the strings are empty, DP will not be formed, right? So we can handle this case separately, right? If n is equal to 0 and m is also equal to 0, lengths are 0 of both the strings, return 0 itself. So let me use this case and then you can say try to run this itself. And tabulation, you can of course see that out of bounds condition are somewhat tricky to handle in tabulation itself, but yeah, overall code becomes very easy, right? Again, we are having some issue. So let's see. Again, here we are having the issue itself. Okay, we can add more base cases itself, right? If n is equal to 0, if only n is equal to 0, return n itself, right? If only m is equal to 0, return m itself, right? This is the base case, the for the, you can say, very first thing we want to handle, right? So they are the things we want to handle to avoid this tabulation from going out of bounds. One thing you can also do, you can make this tabulation array of a greater length in order to handle the edge cases. But yeah, it is passing, right? Not as good as this, but yeah, sometimes lead code also, this particular thing is dependent on the servers of lead code, right? So definitely this code is running just fine, right? So this was the, you can say, tabulation, memoization, and recursion for this problem of edit distance. Very famous problem. I hope you got the deep insight of how do we solve this problem. In this problem, we did not just solve the problem. We saw three approaches. We saw, you can say, three ways. First, the most brutal, you can say, brute force ways. Then some optimization. Then tabulation, not recursion way, right? Iterative way, right? So I hope this problem is clear. I hope you are enjoying the video itself. I hope this content is helping you to excel, DP, right? I hope DP has become easy for you. Do tell me in the comment section, how do you feel about this video? I read all the comments. I, interact with all the comments. So it would be really helpful of you if you give me any feedback, or if you tell me what is wrong, what is right, right? And thanks everybody for joining. You can check out all the codes for, you can say, this playlist in the description itself. I provided the GitHub link in the description. We have also made a Discord community. You can of course join that if you have any doubts regarding these problems. I try to resolve all the doubts, right? So you can of course personally, right? So you can definitely check out that Discord link, and yeah, we can connect there itself. My socials are also there, right? And of course, if you're enjoying the content, please subscribe the channel. We are so close to 500 again and again, right? So that's great, right? So I hope you're enjoying the content, and I hope you enjoyed this video itself. Until the next video drops, bye.